Hello, my name is Patrik Teppo. I'm a senior expert on security architecture, and I will talk about my favorite topic, which is security architecture. So what is then a security architecture? Yeah, we can take a house as an example, and what kind of security controls, or actually things you have for keeping things outside of the house. If it could be the weather, it could be animals, or it could be the bad guys. So a house normally have walls, it had a roof to protect against weather. But to protect against other things, like from a more security perspective, you normally have doors and windows, and they probably have locks and so on. So you actually only have the one that have the key that can enter the house. Inside the house, you may actually add other things, other security controls as well, like surveillance cameras or alarm systems to check that there is no one inside the house that shouldn't be there. On other functions or other things you have in the house, like computers, you may have login and passwords, maybe need fingerprint to access them, or even having a safe where you put your valuables. So the security architecture is then to decide on the right place to put the security controls, and you base that on the threats. Like what threats do you have on the certain asset, in this case the house, and the valuables inside the house. And then also using best practices, because you can look at others, what do they do, and then and use that in your way of building your security architecture on your house, so to say. If we then look at the threats, so in my area, we're coming from the telecom industry, we have threats on our networks out there. And there are three main places where we see the threats. It's on the radio side, because the telco networks, they are exposed over the air, like anyone can access them almost anywhere where there is coverage. So of course this is a place we need to put the right security controls, so no one unauthorized can't use them. Same goes on the other side, when out on the internet or other data networks. There you have access in, and could access into, for example, to the telco network or against devices or phones you have there. And the third part is the management part of it, because these networks are managed by people, and they could do mistakes, which is kind of common. There can also be malicious personnel in the management area doing things they shouldn't do, or they can be kind of influenced from externals by using techniques like phishing or spear phishing to get hold of access to the network, and then doing things that they shouldn't do on the network. So to build a security architecture, we have a set of controls that we can use to put the right to add this control in the right place in the architecture. These are divided in 6 areas, and these are common for all IT systems. It's not only telecommunications. We use this in other IT environment and so on as well. And to start with, we have identity access management, which is the way to give IDs and credentials, username, passwords, for example, to people, so they can access what they are supposed to access only. So the access control is part of this as well. You have your access, you log into a system, and you get the access you're supposed to have. Second area is keys and certificate, which is the base for building encryption and protecting data we're sending over the network and so on. So these are used for the keys for encryption and other like integrity protection techniques. Third area is network security. This is like on the network you have to put certain controls to protect that only the certain data should go in and out, like firewalls, DDoS protection system, like which is actually very, very common now on the internet, that people tries to attack, flood attacks different system, and there we have DDoS attack prevention systems. Fourth area, is logging and monitoring. And we take logs information from everything we have there in the network and try to analyze them and see if something strange is happening. This is very important to see if something happening that shouldn't be happening in the networks. Then we have data protection, which is also related to keys and so on, because these are how we protect the data when it's sent, encrypted over the network, as we say in transit, or when we store it at the disk or something like that, that's at rest. Or when we actually use it, you can actually process data encrypted in some certain aspects of data in use protection. And the last area is hardware and platform security, because we don't have to build everything ourselves in the software. Our hardware and also platforms in certain aspects, they have security controls that we can use. Common things here is like hardware modules that can protect keys, also processing keys and then deriving, for example, session keys, and even do encryption. And other things as well in the hardware is like accelerators to accelerate crypto algorithms and so on. So that was the main things which we have in control when we're building an architecture. Then you have different models of to build a security architecture. And the most common one is called the pyramid security model, has been used for decades. Very common still. And there you have a set of assets, which you see, these have the same access rights. People that can use them have the same access right, and they could be treated in the same way. Then we said that this is a parameter. And on that parameter, we add security controls. So only like the ones that have access can access in. But if you're inside this part of the parameter, you have access to everything there. And you normally also use more than one control in this parameter. Say you have access management, you have to log in, username and password, you have a firewall and so on as well, and also other access control is potentially to access into this network, to actually build up a better defense, as we call it, defense and def in the parameter model. But then we have the problem if someone is inside the network already, or inside the house, as we have in the first example. Today's network are different from where they were before. Before we had networks, you have physical networks, so the connected computers with switches and routers and so on. Now we're having things in the cloud. We're running on, we're sharing the networks between users of the same cloud and so on. So the threat is much higher that someone is already inside and may be accessing parts of your network. So then we need to go for that and have another security model. And what we now have had since some years back, been very hot topic, is to use the zero trust architecture model to protect against that there is probably already someone on the network. We have to assume that our networks are breached, and we have to build controls on each and every asset to protect on these threats. So it differs from the parameter model that we're actually shrinking down and making very small parameters. So they are directly on each and every asset. We still will have the one on the side, but we're also adding in on each and every asset. So even if someone is in, they can't access. They need to have direct access and the right credentials to access these different assets. So that concludes my part.